Hello, my name is Jeremy Strayer, and I'm an assistant professor of mathematics education here at Indiana State University. I'm also here with Dr. Liz Brown, who is an associate professor of mathematics education at Indiana State University as well. She'll be joining us shortly. On behalf of Indiana State University and the Indiana Association of School Principals, we would like to welcome you to this video to help train Math Bowl coaches in the area of probability and statistics. Today, what we're going to do is go through a few questions that are sample questions from the IASP website, and they're all going to focus on probability and statistics. We've broken them up into 4 or 5 different sections, and the first section has to do with taking a set of data, a list of numbers, and saying something about them, doing some type of computation to give us a measure or a label that we could stick on that data set and say, this data set is this, that this number represents this data set in some way. So that's called coming up with some type of measure, a summary measure. There are a lot of different summary measures we could come up with. The mean, the median, the mode, the range. We could do standard deviations, which we're not going to do. That goes beyond this video. But all of these measures tell us something about the data set, and you could break them into 2 different groups. Either the measure tells us something about what's typical in the data set, or it will tell us something about how spread out the data set is. The first question is behind me. In this question it says, find the mean, the median, mode, and range of this data set. So this is just a direct computation type problem. And whenever there's a problem like this, asking for a number of measures, and if the median is involved or the range, one of the best things to do is just put your data set in order right away. So let's do that. 3 is the smallest number, and then I believe there are a couple of 4s, and I'll mark these off to try and keep it straight. There's a 4.5 and 3 5s, a 5.5, see if we got them all, and a 9. So let's stick some labels on this data set to tell us something about it. First of all, let's do a measure of dispersion, the range. The range tells us how spread out the data set. It's one of the easiest measures to compute, and you just take the highest number minus the lowest number, so the range would be 9 minus 3, or 6. So that one's taken care of. Another easy one to compute that can tell us what's typical about the data set is the mode, the most frequently repeated number. And that, in this case, happens to be 5. 4 is repeated twice, but 5 is repeated 3 times. So we've taken care of the mode. The mean is special. It gets a special word in statistics class that we often refer to just as the average every place else. But in statistics, the word average can mean a number of different things. You could use different measures to tell you an average. So the mean is specifically the number that you get when you add up all the numbers in your data set and divide by how many you have. So we can do that in this data set. And then the median, I want to show a familiar way to compute the median once you have a number, once you have your data set in order. The median is the middle number. So one way to find that middle number quickly is just to mark off the lowest number and the highest number, and then the next lowest number and the next highest number, and follow that pattern until you're in the middle. So here, the median, or the middle number, is 5. All right, this next problem is a great example of a problem that asks students to think about the mean and the median without just asking them to compute it. So it's a comparison problem, and let's look at it. It says, which is larger, the median or the mean in the following data set of numbers, and by how much? So here students not only have to compute, but then they also have to make some sort of comparison. So let's go ahead and go through this problem and talk about a quick way that students could find the mean, which they will have to add them up and divide by how many there are. A great way to sum quickly is to think of compatible numbers. So we could think about the 8 and the 12 making 20, and then this 8 and 12 making another 20. And then looking for other numbers that go together to make 10 easily. We've kind of used up what we have. But a 14 and an 11, the 4 and the 1 make a 5, so that makes a 25. That's a nice one. Okay, good. And where else are we? We have two numbers left. This 15 and this 8 will make 23. Or 23. Yeah, okay. Good. So that's 20, 40, 65, 75, 85, and then 88. So these numbers sum to 88. And how many numbers do we have? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8. So the mean is 11. Then we need to find the median. So that's going to be the middle number. And one mistake that students will often make is, especially if they're trying to compute quickly, is they'll just start doing our trick. They'll mark off this 8 with this 12, the 12 with the 15, assuming that the numbers are already in order. So let's make sure we put the numbers in order first before we find the median. So reordering the numbers, our lowest number is an 8. And I think we have 3 of them. And then we have an 11, 2 12s, and a 14 and a 15. Okay, and then we start marking off. Take the 8 and the 15, the 14 and the 8, the 8 and the 12, and now we're stuck. What number's in the middle? Well, 11 and 12 are in the middle. So what will the median be? What we do is take these two numbers and find the number that's exactly in between them. And you can think of it in a couple of different ways. Here you can almost just see it's 11 and a half. It's 11.5. But if the two numbers weren't right next to each other, we could add them and divide by 2 to find the average of the two, to find the middle, what's exactly in between them. So here the median is 11.5. And then we're not quite done. We have to make the comparison. It says which is larger. So the answer would be that the median is, and by how much? By a half. All right. We've been talking about having a set of data and trying to get a picture of what's happening with that data. And so far we've just been finding measures, summary measures that we can just put on that data, put a label on that data so that it can tell us something about what those numbers are doing. Another thing we can do with the set of numbers is to display them and make a picture about those numbers and then read the picture so that it can tell us something about that data set. And that seems a little bit odd. How can you just take a list of numbers and make some kind of a picture of them? But we can. And the first type of picture that we would like to take a look at is what's called a stem and leaf plot. So let's do that here. In this problem it says, if the graph represents the number of spots on some Dalmatian dogs, find the range, median, and mode. So here we have a stem and leaf plot that represents our data set. And the nice thing about a stem and leaf plot is that it is a picture, and it's a picture made up of our actual numbers, the actual numbers in our data set. So let's look at this. What they've done is they've taken our data, and all of this data is either a 1-digit number or a 2-digit number. The smallest ones are 1-digit numbers. The first number is a 5. And the way this stem and leaf plot is set up is that the stem represents the tens place, and then these leaves represent the ones place. So this first Dalmatian has 5 spots. The Dalmatian with the second least spots has 7, and so on. So there are 2 Dalmatians with 12 spots, and we have, it looks like 3 Dalmatians with 27 spots. So that's the way to read a stem and leaf plot. The one with the most spots is there's one dog with 45. So the nice thing is we can get a feel for this data set just by looking at this. The most dogs or out of the ones or the tens or the 20s or the 30s or the 40s, it looks like we have, out of all of those groupings of data, the 20s have the most in them. So we can just see that immediately because the string of leaves is longest. Also, notice what's happened with these leaves is that all of these numbers are put in order. So that allows us to analyze the data as well. So, all right, let's get to the problem. It says find the range. So we can easily see from the stem and leaf plot that the range is going to be 45 minus 5, which is 40. So we can see that quickly. It says another one that we could do quickly is the mode. The mode is the most frequently repeated number. And as we look around, I already pulled it out because we had 3 7s here. So it looks like there are 3 27s, and so that's the most frequently repeated one, so the mode is a 27. And then find the median. Here in this stem and leaf plot, we can do the same trick since we have our numbers in order, and since each row of leaves is placed in order, then we can go ahead and start marking carefully from the smallest, mark off the smallest number and the highest number, and follow that pattern. So now the next smallest number is going to be a 12, and then the next highest number to mark off with that is the 39. So you do have to be careful as you mark off the next smallest number and then the next highest number. But if we keep going in this way, we see that the median would be 24. Okay, in this question, we're going to look at another way to display numerical data. We've talked about stem and leaf plots, and now we're going to look at one called a line plot. The question calls it a line plot. We've also seen it often referred to as a dot plot. So let's take a look at this problem. The line plot shows the number of minutes 12 different students spend on homework. What is the range of the data? So in this display, we have a number line across the bottom, and it's split up by 5s, going from 20 to 50. And then each X above the number line represents one of your data points. So one student spent 20 minutes doing homework. Another student spends 25. 3 students spend 40 minutes. And on the high end, 2 students spend 45 minutes. So this is another nice display that actually uses the data in the data set to make the picture. So that's nice, and you can easily, if we understand what this display is, we can easily find the range, which would be 45 is the highest, minus 20 is the lowest. So that number, when you do the subtraction, 25 is going to be the range. A couple of other things you can see from this display is you can easily see what the mode is, what's the most frequently repeated number. And in this case, 35 shows up 3 times, and 40 shows up 3 times. And so different people make different decisions about what the mode would be. Some people say there's 2 modes, but often they just say that there's no mode if 2 different numbers or more are repeated the same number of times like this. So I would say there's no mode here.